Hello, this lesson is on isotopes and average atomic mass. And an isotope is going to have the same number of protons, electrons, but they're going to differ in their number of neutrons. So isotopes are going to come in a set. They're each going to have the same number of protons because the protons tell you what element it is. They're going to have the same number of electrons, but they're going to have a different number of neutrons. The protons and electrons are responsible for chemical behavior, so isotopes are going to chemically be alike. So here we have three isotopes of carbon. We have the carbon-12, carbon-13, and carbon-14, and you'll notice that the most prominent one is the carbon-12. It has 6 protons and 6 neutrons. There's also carbon-13, which has 6 protons and 7 neutrons, and carbon-14, which has 6 protons and 8 neutrons. So atomic mass is going to be a weighted average mass of the atoms in a naturally occurring sample of the element. And the weighted average mass is going to reflect the mass and relative abundance of the isotopes as they occur in nature. So to find the average atomic mass, you're going to take your percent abundance out of percent form. So whatever percent abundance they give you, divide by 100. You're going to take the atomic mass, multiply it by the abundance, and you're going to do that for each isotope in the set. Then you're going to add those values together, and that should give you the average atomic mass. So if we were to calculate the atomic mass of bromine, 50.69% of the 78.92 AMU, and it is 49.31% of the 80.92 AMU. So remember, the first thing you have to do is take it out of percent. So to get 50.69% out of percent form, you divide by 100. If you're going to divide by 100, you're simply moving the decimal 2 places to the left. So 1, 2. Once you have it out of percent form, you're going to multiply by the mass. So 0.5069 times 78.92. And that gives us essentially 40.00. And then you're going to do the same thing with the second one. We're going to move our decimal 2 places to the left to get it out of percent form. So then we're going to take our 0.4931. We're going to multiply it by its mass, which is 80.92. And that gives us 39.90. So now you take these two, add them together, and we get 79.90 is going to be our average atomic mass. And if you look up bromine on the periodic table, its mass listed on the periodic table is 79.904. Should be very similar. Now, it's not always given to you in this percent AMU setup. Sometimes it may be given to you like this, where it tells you have 80% of iodine 127. So this is the element, and this is the mass. So we have 80% of iodine 127, 17% of iodine 126, and 3% of iodine 128. The steps are going to be the same. Take your percent out of percent form. So you're going to have to move each decimal 2 places to the left. So 80 is going to become 0.80. You're going to multiply it by its mass. So this number at the top of each of these is the mass number, which is essentially the mass. So 80, or 0.80, sorry, times 127 gives us 101.6. 0.17 times 126 gives us 21.42, and then the last one, 2 spaces, would be 0.03 times 128. That gives us 3.84. Now add all of these up. And that gives us 126.86. And if you look on the periodic table at iodine, they have 126.9, which is very close. So that's finding average atomic mass.